This is the second video for the Unit 11 review. We're picking up with question 7. The first video had 1 through 6. We'll see how many questions we get through in the second video and then pick up from there in the third. So in problem 7 here, we're solving. So the first thing we're going to do is divide by 5 on both sides here, so that 5 cancels. We're left with x minus 3 to the 2/3 power equals 125 divided by 5 is 25. Alright, and then we apply our process that we've used before. This variable is locked up inside this parentheses raised to this fractional exponent, this rational exponent. So we'll raise it to the reciprocal power, so it cancels. 2/3 times 3/2 is 1, so we're raising it to the first power basically. So now it's gone, so we have x minus 3 equals 25. Also, we have to raise the right side to the 3/2 power since we did it on the left, so we're to this point now. So now x minus 3 equals, so let's apply our power over root. So it's third power, square root. I know the square root of 25, so we'll do that first. Square root of 25, and then we'll raise that to the third power. So next step, x minus 3 equals, square root of 25 is 5. We need to cube that. So x minus 3 equals 5 times 5 times 5 is 125. So we're to this point now. And we just add 3. And we get x equals 128. That's one solution. And then because we took the square root before, I should have wrote this right here. It's plus or minus 5 cubed. So then we have to come over here and solve x minus 3 equals negative 125. Add the 3 to that. And we get x equals negative 122. So those are our two answers, negative 122 and 128. So again, back to this, I should have wrote the plus or minus here. When you take the square root of 25, the square root of 25 is plus or minus 5, and then you have to cube that. So it's positive 125 and negative 125, so you end up having to solve two equations because there are two possible solutions to this. Alright, so let's look next at number 8. Alright, problem 8 of your Unit 11 review. We're solving again, so we're going to divide by 2 first. That gives us p to the 4/3 power equals 162 divided by 2 is 81. And then we want to raise to the reciprocal power, so we're raising to the 3/4 power here. On both sides, that'll cancel. It becomes 1, so p to the first power is just p. And then it's power over root, so we're going to take the 4th root of 81 and then we'll cube that. So the 4th root of 81 is, and by the way, we're taking, I need to do this right here. We're taking an even root, so we have a plus or minus there. So p equals plus or minus, the 4th root of 81 is equal to 3, so plus or minus 3 cubed. 3 cubed is 27, so p equals plus or minus 27. So it equals positive 27 and negative 27. So we have two answers there, positive 27 and negative 27. All right, so again, anytime you take the even root, square root, 4th root, 6th root, you have to do the plus or minus part. All right, so let's move on to number 9 next. All right, number 9. So quick review. On these where we're sketching, if it's raised to the 1/2 power, 1/4 power, 1/6 power, when the denominator is even, they have the square root shape like this. If this value is 1/3, 1/5, 1/7, so the denominator is an odd number, then it has this flattened S shape like that. Okay, so just a quick review on what we worked on during that part of the unit. So let's rewrite this. It's 4, and then we have to factor out the negative, x plus 8, close the parentheses there, and raise it to the 1/2 power and subtract 2. So we have to factor out that negative anytime you have the negative in front of x. That way we can see actually what's happening and apply our specific rules. So let's see, we need to stretch by 4, so a vertical stretch factor of 4 by a factor of 4 really in our sketch here, we're not going to be able to show that in a lot of detail. This negative here makes opposite x. Opposite x, we're going to change the sign. And then we're going to move it to the left 8. Left 8. And this subtract 2 there moves us down 2. And the opposite x, what that ends up doing, if you make your x's opposite, you end up reflecting over y. That's what it does, reflect over y. Okay, so all of that listed out. Now we can sketch it. So our anchor point for these, it's going to be left 8 and down 2. So it's right here at -8, -2 for the anchor. And then because it was reflected over the y, instead of going this way, it's going to go this way. So we'll draw that in. And then it is vertically stretched, so it's going to increase at a faster rate. So something like that. And that answers that question for number 9. Alright, problem 10, we're asked to sketch this. It's raised to the 1/3 power, so remember that's going to have this flattened S shape, which is normally anchored at the origin right there. And then we'll apply our transformations. So we have a vertical stretch factor of 2. Factor of 2, that's this 2 right here. This +1 here moves it left 1. And then this +4 out here moves it up 4. So our anchor point's left 1 up 4. So that's pretty straightforward on this one. So we'll put our anchor point left 1 up 4. So that would be -1, 4 is this middle of our flattened S shape. And then we'll do our best to sketch that thing in there like this. And our anchor point again was at -1, 4, and that answers that one. The main thing, I just want you to get the rough shape. For me it's a little hard to draw honestly, but as long as you have the rough shape, I'm good with it. Alright, let's move on to number 11. Alright, number 11 on your unit 11 review. Write the function that produces this graph. So the shape is that flattened S, so that's going to be raised to the 1/3 power. I know that. And then its normal anchor point, it is going, there are no reflections because it's going the way that the normal starting function goes. So no reflections, but it normally is anchored at 0, 0. So it's right 1, 2, 3. So I need to write the function right 3. And then up 1, 2, 3, 4, 5, 6, up 6. So write the function f of x so that it's moved in that way. So it would be x right 3 is subtract 3, all raised to the 1/3 power, and then up 6 is a +6 out here. So that answers number 10, x minus 3 all raised to the 1/3 power plus 6. Let's move on to 12. Alright, number 12 has the square root shape, and as I mentioned to you when we worked on this lesson during the unit, if it has this shape, it's raised to the 1/2 power. That's all we're doing. It could be 1/4, could be 1/6, but I'll make sure they're all 1/2 power. And if it has that flattened S shape, it's always 1/3. So this one will be raised to the 1/2 power. So normally that one should be anchored here, going back this way. So it is reflected over Y. Reflect over Y. So we'll need to do that. And then the anchor point should be here at the origin. So it's down 1, 2, 3. Down 3, and it's moved left 1. So I need to write the function so that those things take place. Alright, so we'll have f of x equals, I'm going to put a bracket here with a negative. That's going to reflect over, I didn't finish writing that, reflect over y. So that'll reflect over the y, then parentheses, and we need left 1, so that's an x plus 1, and close that parentheses. And then close our brace there and raise it to the 1/2 power, and then the down 3 is a -3 out here. So because it's reflected over y, the x's are opposite, so you have to have this negative inside this other set of parentheses. If you just wrote it like this, then that would be actually a reflection over the x-axis, making the y's opposite. Okay, so it has to be this way. You need two sets of parentheses, or a set of parentheses and brackets or braces there. Alright, so let's move on to one more in this video probably. Let's go to 13. All right, last one for this video, number 13. So sketch this graph. So we have exponential growth because the base is 2, and we're going to follow our process here. So we're going to list what's happening to x, what's happening to y, and then make the original table, then the new table from those transformations, and then sketch it. So x, what's happening? Well, it's moving to the left one because of that plus 1 right there. And then y is multiplied by 3. It's a vertical stretch, but to the actual original y values, I'm going to abbreviate, multiply by 3. That's this 3 in the front. And then it's up 4 from this plus 4 out here. Okay? So same as all other functions as far as the rules of how the transformations work. So now let's make an original table, and we'll make the new table and sketch from there. So the original is for exponential growth, it's always 0, 1, and 1, the base. The base is 2. This is the base. That's what's raised to the exponent. So the new table, also it has a horizontal asymptote at y equals 0. So the new table, we're just going to apply these transformations to x and these transformations to y. So left 1, the x's go left 1. So I was at 0, left 1 takes me to negative 1. I was at positive 1, left 1 takes me to 0, so those are my new x's. Now the y's. You have to follow order of operations. Multiply by 3 first, then add the 4 to move it up 4. You can't add 4 and then multiply by 3 because that'll mess it up. So follow order of operations. We multiply before we add. Alright, so multiply by 3. So you multiply this 1 by 3, that makes it 3. Then up 4 from there takes you to 7. Okay, you're at 1, multiply by 3, that's 3. 3 plus 4, 7. So that's why you end at 7. Alright, next one. We have a y value of 2, multiply by 3, that's 6. Add 4 to that, that's 10. And then my horizontal asymptote for this graph will move up 4. It was at 0, so now it's at y equals 4. So now we have this new table. We have everything we need to sketch this graph. So as long as you did your table, your new table correctly, you followed the steps, the graph will fall into place. So we have horizontal asymptote across here at y equals 4. We have 0, 10 up here. And we have negative 1, 7 right here. That forces the graph to be shaped like this based on that information. So we'll label those points 0, 10 and negative 1, 7. Alright, that's it for number 13. And that's it for this video, so we'll pick up with 14 in the third video.